Okay, so today we're talking about the difference between an expression and an equation. So when we talk about an expression, its official definition is a mathematical phrase that can contain numbers, variables, and operators. And an equation is a mathematical sentence that shows two equivalent expressions. Now, while those are great formal official definitions, I don't expect you guys to remember those two. Instead, I'm going to show you a hack that'll show you the difference between an expression and an equation. So before we get to that hack, there are three different ways that we can represent an expression and an equation. Those are going to be a numerical representation, an algebraic representation, and a verbal representation. We're going to start with the numerical representation. So a numerical representation, the word numerical sounds like the word numbers. So numerical representations contain only numbers and operators, okay? So let's start with an expression. So we're going to just do 4 different examples of a numerical expression. One of those examples could be 4 plus 5. Okay, I have only numbers and an operator. Another example could be 21 divided by 7. Again, only numbers and an operator. I could have 17 times 3, which again, numbers and an operator. And then 16 minus 6, again, numbers and an operator. So these are all expressions. We've got numbers and a numerical representation. So we have numbers and operator. But now let's talk about what it looks like to have a numerical representation of an equation. So again, it says a mathematical sentence that shows two equivalent expressions. So I'm going to use my first expression of 4 plus 5. Okay, again, it's just an expression. But to turn it into an equation, it needs an equal sign and the answer to the expression. So 4 plus 5 equals 9. This is an equation. So your way to remember what an equation is the first 4 letters of equation are EQUA, which are the same first 4 letters as equal. So equations have equal signs. So where it talks about having two equivalent expressions, if I cover up the equal sign, 4 plus 5, that is an expression. If I cover up the equal sign and just have 9, that is an expression. 4 plus 5 is equivalent to 9. So there are my two equivalent expressions. So 21 divided by 7, that expression needs an equal sign to make it an equation and what it's equivalent to, which would be 3. 17 times 3 needs an equal sign and what it is equivalent to, which would be 51. And then 16 minus 6 needs an equal sign and what it is equivalent to, which is 10. Okay, so again, equations have equal signs, expressions do not. So that was our numerical representation where it just has numbers. Our second type of representation is called an algebraic representation. And this is where it contains one or more variables. Okay, so let's define what a variable is. I'm going to come down here to the bottom. So when we talk about variables, okay, you're going to see variables starting kind of from here on out a lot in math. So the definition of a variable is it is a letter that represents an unknown number. So we're getting to the part of math where we're going to start solving for variables. We're going to start trying to figure out what these letters represent. So some of the most common examples of variables that you'll see in math is they can really be any letter. But the most common ones you're going to see are the letters X, Y, and N, those 3. The only 2 that they typically choose not to use are the letters L because it looks like a 1 and E because E actually represents something different in math. But if you see a letter thrown into there, that is a variable. And again, it represents an unknown number. So let's do some algebraic representations of an expression. So remember, expressions do not have equal signs. It's just one mathematical phrase. So an example could be X plus 4. I have a variable, an operator, and a number. It could be 17 minus B. Again, a number, an operator, and a variable. It could be 700 minus x, or something like 2 times y. Okay, again, all of these have a letter that is representing an unknown number. So now let's take these and let's turn these into equations. So again, equations have equal signs. So I could say that x plus 4 equals 10. So the way that we would solve for this variable is what number, if I add 4 to it, would give me 10? Well, that would be 6 plus 4 equals 10. I could say that 17 minus b gives me 6. So again, I'm looking for, if I take 17 and I subtract this unknown amount, b, what would give me 6? So b represents 11. I could say that 700 minus x gives me 400. So again, I'm looking for this unknown number that when I take 700 and subtract it from it would give me 400. Well, x would represent 300 in this situation. Or I could say that 2 times y gives me 24. So I'm looking for what number, what's the unknown number that when I multiply it by 2 gives me 24. So y would represent 12. And the last type of representation we have is a verbal representation. So verbal representations are all about words. And we're only going to do 2 examples here because there are 2 words that I want you guys to look for, okay? So let's start with the expressions. So one example of an expression could be the product of 7 and 10. Okay, so again, I use nothing but words. Sometimes they'll just write the number. Sometimes they'll actually spell it out in word form. But this is nothing but words here. We have no operators here. Okay, I could also say that the sum of 4 and x. Okay, so again, I have nothing but words here. They did spell out the number 4. It would have been okay if they just wrote the number 4. And I have a variable, okay? So verbal representations can have numbers, they can have variables, and they have the word form of the operator. But let's take these now and let's turn these into equations. So we said that equations have to have equal signs. So yes, I could write the word equals, but that's too straightforward. There are 2 other words, keywords that we look for that tell us that it's going to be an equation. So I'm going to do the first example using one of the words. So we're going to still use the sentence, the product of 7 and 10. And here's the first magic word. It's going to be the word is. 70. Okay, so the product of 7 and 10 is 70. So that word is there represents an equal sign. So I could take this and write it as 7 times 10 equals 70. The other word that we can use is, let's go back to our second example and write the sum of 4 and x gives. So is and gives are our 2 magic words, 12. So I could write this as 4 plus x equals 12. So x here would represent our unknown number of 8. So our 2 words that we're going to look for are the words is and gives. Now, there is an exception to the word is. Okay, our one exception to the word is if it's followed by the words is greater than or is less than. Now, if you see the word is followed by greater than or less than, we don't use equal signs to show greater than or less than. We use this for a greater than, this for a less than. Those 2 signs right there are what we call inequalities. And we'll talk about those later on, but those are different than an equation. So again, if it's just is a number or is for some other words, as long as it's not followed by greater than or less than, that tells you it is an equation.